Hi everyone. Today we are going to look at double angle formulas. With the previous lesson, we learned about compound angle formulas, and today we are going to look at double angle formulas. So the double angle formulas show how the trigonometric ratios for a double angle 2 theta are related to the trigonometric ratios for the original angle theta. So we have some formulas here. For sine 2x, we have 2 sine x cos x. So for cos 2x, actually we have three different formulas. One is cos square x minus sine square x. Other one is 2 cos square x minus 1. And the other one is 1 minus 2 sine square x. For tangent 2x, we have one formula, 2 tan x over 1 minus tan square x. So maybe I will show you how to get those formulas or how they got these formulas using the compound angle formulas. For example, sine 2x, we can write this as sine x plus x. Okay. Now, if we actually apply the sine x plus y compound angle formula, we get sine, as you see now, x is x, but y is also x, comparing to this formula. Then you get sine x cos y, sine x, but your y is also x, so cos x, plus cos x, and then your y is another x, so sine x. So basically you get sine x cos x plus cos x sine x. So these are the same things. So then you get 2 sine x cos x. This is what you have for sine 2x formula. Okay, so we can do the same thing for cos 2x. Cos 2x, you can write this as cos x plus x. Okay, so again, this first angle, you can take it as x, second as y, and apply this cos x plus y formula. Then you get cos x, cos y, but your y is another x, minus sine x, sine y, but again, that y is another x, so sine x. So basically, you get cos square x minus sine square x. This is the first formula you have. So how about the other two formulas? How to get those? So you can write cos square x as 1 minus sine square x. And you know that it's coming from the identity cos square x plus sine square x equals 1. If you isolate cos square x from here, you get 1 minus sine square x. So you end up with 1 minus 2 sine square x, so which is this formula. Also, if you, from here, if you replace sine square x with 1 minus sine square, 1 minus cos square x, 1 minus cos square x, and expand this bracket, distribute the negative sign, so you end up with cos square x minus 1. Okay, so actually, again, these formulas can be get from compound angle formulas. So let's do some practice questions here. So use a double angle formula to rewrite the following. Okay. So we have sine tan theta. We are using double angle formulas. So if you compare with this tan theta with 2x, so here we can write 2 sine. If this was 2x, so let me write it here so you can see it better. If this was sine 2x, then the right side of the formula would be 2 sine x cos x. If this is tan theta, what angles should we put here then? Right? So this x is half of this angle. X is half of 2x. Then whatever I put here and here should be half of that tan theta. So then 5 theta and 5 theta would be the answer. B, we have tangent 7 theta. We are going to use again double angle formula. So we have tan 2x equals, so if this was tan 2x, then we would have 2 tan x over 1 minus tan square x. But we don't have 2x, instead we have 7 theta here. Then what angle we should put here instead of x? So again, this x is half of 2x. And whatever I put here must be half of this angle. So half of 7 theta is 7 over 2 theta. Okay, so let's look at example 2. Express each of the following as a single trigonometric ratio. This time, actually, instead of giving us the left side of the formula, they are giving us the right side of the formula. Okay, so if this was 2 sine x cos x, then that would be equal to sine 2x. So 2 is matching, sine and cosine is matching, but instead of x, we have 7x here. Okay, so what should we put here then? Now check, this angle, 2x, is 2 times these angles. But then whatever I put here must be 2 times this angle. So 7x times 2 gives you 14x. Next one, we have 2 tan 3x over 1 minus tan square 3x. So we're going to write it as a single ratio. So if, and again, I'm going to take the right side because this is matching with the right side of the tan formula. Okay, if this was 2 tan x over 1 minus tan square x, then the answer would be tan 2x. Okay, so again, 2 is matching, 1 minus is matching, so tan and tan square is matching. The only difference is, as you see, instead of x, we have 3x here. So if this was x, then on the right side, we would put 2x. So it is 2 times this angle. Then we will have here 2 times this angle, 3x, which is 6x. Next one, we have 1 minus 2 sine squared theta over 4. So if you look at it, so it looks like this formula, right side of cos 2x formula. Okay, so if we had 1 minus 2 sine square x, that would be equal to cos 2x. So if you compare these two, instead of x, we have theta over 4. That is the only difference. So again, on this side, this 2x is 2 times this angle x. And whatever I put here as an angle should be 2 times theta over 4. So theta over 4 times 2 gives you theta over 2. Example 3. This is express each of the following. Actually, there's only one example. So express the following as a single trigonometric ratio and then evaluate. We have 2 cos squared 5 over 12 minus 1. If you look at these double angle formulas, we see that, cos 2x equals 2 cos squared x minus 1. So it looks like right side of this cos 2x formula. If we had 2 cos squared x minus 1, then we could simplify it as cos 2x. So as you see, this formula is matching with our question. The only difference is x now is 5 pi over 12. Then whatever we put here, right? So as you see, 2x is 2 times this angle x. Then we can multiply this by 2. That gives you 5 pi over 6. And of course, you can find the value of 5 pi over x. The related acute angle for this is pi over 6. If you sketch this angle, this is what you get, 5 pi over 6. Then the beta is pi over 6. So cosine pi over 6 is root 3 over 2. But 5 pi over 6 is in second quadrant, and in the second quadrant, cosine is negative. So you have negative root 3 over 2. Let's look at example 5. Angle theta lies in the second quadrant and sine theta is 7 over 25. Find the exact value of cos 2 theta. Cos 2 theta. So for cos 2 theta, you have 3 formulas. So you need to pick which is useful to you. Here, we could have, if we have the first formula, cos squared x minus sine squared x, then besides sine theta, we also need cos theta to be able to use this formula. So if you look at the second formula, you have 2 cos squared x minus 1. But again, we don't have cos here. We could calculate. But the easiest way, as you see, would be using the third formula, 1 minus 2 sine squared x. Because we already know what sine theta is here. So if we apply the third formula, so we say 1 minus 2 sine squared theta. So we can now put sine theta, 7 over 25, and then we need to square that. From here, we get 1 minus 2 times 49 over 625. This gives you 1 minus 98 over 625. And then finally, we get, if you have a common denominator here, 527 over 625. Part B, find the exact value of sine 2 theta. Sine 2 theta. We have only one formula for sine 2 theta, which is sine 2x is 2 sine x cos x. So this is going to be 2 sine theta cos theta. So we already know what sine theta is. And it looks like we have to get the cos theta. Okay? So they're telling you that theta is in second quadrant. So you can sketch this angle. Sine theta is y over r. So this is 7, r is 25. And this is your angle theta. Okay, so to be able to get cos theta, we need x over r. So we need to get the x coordinate here. Okay, so let's calculate that. X is going to be, using Pythagorean, square root of 25 square minus 7 square. Okay, so that is going to give you 24. Okay, so x is 24, but because x is on the negative x-axis, so then we have negative 24. Then cos theta is negative 24 over 25, x over r. So negative 24 over 25. If you multiply these three numbers, 2 times 7 times negative 24, you get negative 336. And 25 times 25, 625. Let's look at example 4. So they are giving us cos 2x, which is negative 5 over 7, and we need to find cos x. Okay? So they are giving us cos 2x, and we need to find cos x. So then we need to pick a good formula that will help us for this question. Okay? If you pick the first formula, actually that depends on cos and sine. You have now, you know cos 2x, but you don't know cos x and you don't know sine x. And you are looking for cos x. So if you look at the second formula, you know cos 2x and you are looking for cos x. So it looks like this formula is going to help us. Okay? If you pick the last formula, you know cos 2x, you can calculate sine x. But we don't know, we don't need sine x, we need cos x. So it looks like the second formula is the best for this question. Cos 2x equals 2 cos square x minus 1. Cos 2x is negative 5 over 7, 2 cos square x minus 1. So we can isolate cos square x from here. So take negative 1, move it over. So you have negative 5 over 7 plus 1. So have a common denominator. Simplify. You get 2 over 7 equals 2 cos square x. Divide both sides by 2. You get 1 over 7 equals cos square x. And then we are going to take square root of both sides. So that gives us plus and minus square root of 1 over 7 or 1 over root 7. If you rationalize the denominator, plus and minus root 7 over 7 is the answer. Example 6. The angle theta lies in the interval where theta is greater than or equal to pi, less than or equal to 3 pi over 2. And they are giving us cos square theta, which is 12 over 25. Without using a calculator, determine the exact value of cos 2 theta. Okay, so cos 2 theta, again, we have 3 formulas. Cos square minus sine square. Well, we're only given cos square for now, right? So if you don't want to calculate anything else for this question, then we should choose the second formula, because we are looking for cos 2x and we have cos x. So cos 2 theta is 2 cos square theta minus 1. 2, 12 over 25 minus 1. So 24 over 25 minus 1. And this gives you a negative 1 over 25. Okay, next question. Sine 2 theta. We have only one formula for this. 2 sine x cos x. We will have 2 sine theta cos theta. 2 sine theta cos theta. Okay. So for now, we don't know sine theta. Looks like we will have to calculate. Even cos theta, you need to calculate from cos square theta. So let's do that. Okay, so cos square theta equals 12 over 25. Then cos theta should be plus and minus square root of 12 over 25. Okay. So, also, but there is another information here. It says theta is between pi and 3 pi over 2. So pi is here, 3 pi over 2 is here. So this is 0. So then the angle that we have is right here in the third quadrant. So using cast, we know that only tangent is positive in the third quadrant, so cosine must be negative. So we cannot take the positive value actually. So we can only take the negative root 12 over 25. So let's simplify this radical. So root 12 is 2 root 3, and square root of 25 is 5. So this is cos theta. You also need sine theta. Then here we can calculate sine theta. Okay. So again, cos theta is x over r. R is 5, and then x is negative 2 root 3. We need to calculate this y coordinate. Okay. So that will give us square root of 5 square minus 2 root 3 square. This is 25. That is 12. So root 13. But because we are on the negative y-axis, so that is going to be negative root 13. Then sine theta is negative root 13 over 5. Okay, so let's put that information now in the formula. 2 times sine theta is negative root 13 over 5, and cos theta is negative 2 root 3 over 5. So this will give us 2, so positive, negative gives you positive. 2 times 2 is 4. Root 13 times root 3 is root 39. And 5 times 5 is 25. Okay, the next question. So we are going to find the exact value of cos 3 theta. The formula sheet, if you look at, we have 2x, but actually we don't have 3x, right? So we have to do something else here to be able to get the exact value of cos 3 theta. Oh, but if we write this 3 theta as theta plus 2 theta. And now instead of using double angle formula directly, now we can use compound angle formula. Theta plus 2 theta, we can use cos x plus y formula. That will give us cos x cos y, cos theta cos 2 theta, minus sine x sine theta times sine 2 theta. Okay, well, this is still not helping us very much. We need to get rid of those 2 thetas and try to write everything in terms of cos theta and sine theta. Okay, so that we have cos theta, we have sine theta. Actually, for now, we calculated cos 2 theta and sine 2 theta, but we want to write everything in terms of cos and sine theta here. What we can do now, we can also apply double angle formulas. So instead of cos 2 theta, for example, you could pick one of those. I'm going to pick, let's say, 2 cos square theta minus 1, 2 cos square theta minus 1. So I'm going to keep sine theta. And instead of sine 2 theta, I'm going to say this is sine 2 sine theta cos 2 theta, using sine 2x formula. So this will give us 2 cos cube theta minus cos theta, just distribute. And here you get minus 2 sine square theta cos theta. Now you know cos theta, you know sine theta. You can actually submit them here and calculate what cos 3 theta is. Exactly. Actually, we could also, go further. Let's say if the question was, write everything in terms of cos theta only, we could also do that. Okay, so 2 cos cube theta minus cos theta. Then I would replace sine square theta with 1 minus cos square theta again. Sine square theta plus cos square theta equals 1. Then sine square theta is 1 minus cos square theta. So 1 minus cos square theta. So if we expand this, if it is hard to distribute this way because we need to multiply the terms in the bracket with 2 and also with cos theta. So we can just put 2 cos theta together and then distribute it. So you get minus 2 cos theta and plus 2 cos cube theta. Actually, when you do this, you get a more simplified formula for cos 3 theta. So you end up with 4 cos cube theta minus 3 cos theta. So you already know what cos theta is, negative 2 root 3 over 5. Now we can put this in here, sub it in here. Okay, so negative 2 root 3 over 5 cube minus 3 times negative 2 root 3 over 5. Okay, so let's calculate this. So negative 2 cube is negative 8. 3 root 3 cube is 3 root 3. 5 cube is 125. If you multiply these two, you get 6 root 3 over 5. Okay, so simplify this further. So you need to multiply 4, 8, and 3. So you get 96. So negative 96 root 3 over 125 plus, and now you can have a common denominator with this. So you need to multiply the second fraction by 25 over 25. That gives us 150 root 3 over 125. So you end up with 54 root 3 over 125. So the exact value of cos 3 theta is 54 root 3 over 25. Okay, so let's take the last part, cosine 1 over 2 theta. So if you try to use these double angle formulas, cos 1 over 2 theta, if you apply, let's say, cos 2x formula, okay, well, the right side would be, let's say if we are using the second one, you would get 2 cos square x minus 1. So if you apply this to 1 over 2 theta, if your x is 1 over 2 theta, 2 cos square, so this angle is half of this angle. So half of 1 over 2 giving me 1 over 4 theta minus 1. So it looks like if I use this double angle formula this way, it is not helping me. Okay, because to be able to calculate the exact value of cosine 1 over 2 theta, I should be able to write this in terms of cos theta or sine theta, because we already know what cos theta and sine theta for this question. Okay, but if I apply this way, then I end up with 1 over 4 theta. So this is not helping. What can we do is that, how about if we do this, right? How about you kind of find the relation this way. So we have cos 2x equals to 2 cos squared x minus 1. How about if I say that x is 1 over 2 theta? Okay, then on the left side, this again, so that 2x is 2 times this angle. So I can multiply 1 over 2 theta by 2, and that would give me cos theta. Okay, so now this is helping because now I can isolate cos 1 over 2 theta from 1 over 2 theta from here because I already know cos theta. So I can write cos 1 over 2 theta in terms of cos theta. So let's do that. So we said cos theta equals 2 cos squared theta over 2 minus 1. So I can move negative 1 to the left side, or directly you can put cos theta value here and go from there too. So we got cos theta being, you can first isolate cos theta over 2 and then substitute cos theta, or right from the beginning you can substitute cos theta and then isolate cos theta over 2. Okay, so cos theta is negative 2 root 3, negative 2 root 3 over 5. So we can move negative 1 to the left. So now have a common denominator here. Okay, and then we get negative 2 root 3 plus 5 over 2. Sorry, over 5. Now we can divide both sides by 2. This gives us negative 2 root 3 plus 5 over 10. Now we can take the square root of both sides. Okay, so then we get cos theta over 2 equals plus and minus square root of 5 minus 2 root 3 over 10. But let's check one more thing here. Okay, so they told right from the beginning, we know that theta is in quadrant 2, quadrant 3. Okay, so that is theta, quadrant 3. Then half of theta would be there, right? Because based on that, so we will know if we need to pick positive or negative square root of 5 minus 2 root 3 over 10. If theta is in quadrant 3, actually half theta would be in quadrant 2. How would we know that? So we can take a few sample values to try it, okay? Let's say theta is in quadrant 3, let's say it is 200. Half of 200 is 100. So 100 degree is in quadrant 2. Take another sample value. Let's say you have an angle 240 in the third quadrant. Okay, so if you take half of it, that would be 120. Again, it is in quadrant 2. So if you have an angle in quadrant 3, half of it is going to be in quadrant 2. So this is theta over 2, and that is another theta over 2. Okay, so basically, if your theta over 2, angle theta over 2 is in quadrant 2, then as you see, only sign is positive, so cosine must be negative. So I cannot actually take the positive one, but only take the negative value. So negative square root of 5 minus 2 root 3 over